in AP style problem number 4, sulfuryl chloride, SO2Cl2, is put into a container, and we can see from the initial write-up that we've got an equilibrium expression, or equilibrium equation right here. We're told that it is endothermic. We're given how many grams of sulfuryl chloride is put into a 1 liter container, and what the temperature is in Kelvin. This 1 liter container is very convenient because now we know that all of our molarities are going to be the same as the moles of these chemicals. So, first question, what's the pressure going to be if no dissociation occurs? So that's like saying what happens at time is 0 when it's 100% right here on the reactant side. Well, that's easy because they tell us how many grams we have. So we just need to use PV equals nRT, and the pressure is going to be the number of moles times RT over V. The number of moles is going to be the grams times 1 over the molar mass. So 135.0 is the molar mass I get when I add up 1 sulfur, 2 oxygens, and 2 chlorines. Then I've got my R, my T, and it's all in 1 liter. So partial pressure is 0.8 atmospheres. So then it gets to equilibrium, and the total pressure is found to be 1.43. What's the partial pressures of each of these things? Keep in mind that from our equation, we know that the concentration of each each product, the sulfur dioxide and the chlorine gas, are going to be the same. And we know that the concentration of the sulfuryl chloride is going to be reduced by the same amount. So this is an ice table. At the beginning, we know the concentration, or rather the pressure, and we know that the pressure of our other two are 0. We're going to lose x, and we're going to end up with 0.8 minus x. We're going to gain x, so each of those products will have a concentration of x. Now, this is not using the equilibrium expression. We're just trying to find partial pressures. So the pressure total is the pressure of each one of them added together. And we know the total pressure is 1.43, so the pressure of sulfuryl chloride will be 0.8 minus y, and the pressure of sulfur dioxide and of chlorine gas will be the same. Apparently something happened between up here, where I was calling my unknown x, and down here where I started calling the same unknown y. Don't know how that happened, but it did. But this is easy algebra. We find out that y equals 0.63 atmospheres. Right? So if y is 0.63, that means that the pressure of SO2 and Cl2, which are the same, are both 0.63, and the pressure of sulfuryl chloride is 0.8 minus 0.63, or 0.17. Now, give the expression for the equilibrium constant, either Kp or Kc. This type of question is designed to catch the unwary. You've done everything so far in pressure. Switching to Kc now would be a lot of work. So if I have the choice, I would rather do it all in Kp. Kp is the pressure of the products divided by the pressure of the reactants. If I had any coefficients, I would be raising them to exponents, but I don't. It's all 1 to 1 to 1. So this squared term over here is not due to the coefficient. It is because the partial pressure of sulfur dioxide and the partial pressure of chlorine gas are the same. So I end up with 2.3. And this would be in atmospheres because This would be atmospheres squared, and in the bottom we would have just atmospheres. So we end up with one left over. Usually we do not write any units for K, so I only did it because they specifically asked for it. And then if we raise the temperature, what effect would this have on the equilibrium constant? And explain briefly. Right? Remember from the beginning, this is an endothermic reaction. Now, when you answer a question like this that comes in two pieces, where it says, what effect would this have? And then explain, you should answer it exactly in that order. It makes the grading easy. So the very first thing you should say is something like this. The value of the equilibrium constant would increase. Now, it's okay if you figure that out before you write that down, but you should make that match. What effect would this have? And that is the first sentence that happens. Then your explanation follows it. So, to make sure we understand why, as an endothermic decomposition, that means heat is a reactant. So when you add extra reactants, heats, the equilibrium shifts away from that side. If heat is a reactant, it'll shift to the right to make more products. So we're going to increase the value because K is figured out by products divided by reactants. K at 500 is greater than K at 375.